Here we're going to have a look at Kirchoff's laws. There are two Kirchoff's laws. The first one is called the current law, the first law, and this is the one that tells us that the current here, the current coming into this junction, we call it I1, and the current here, which we call I2, those two, when added together, equal I3, just here. So we can say I3 equals I1 plus I2. Now it may be that we want to show this equation a different way. We could say 0 equals I1 plus I2 plus I3. If you show it that way, that's assuming that all the currents are flowing into the junction. So for example, if that one was 4 and that one was 2, they add together to 6. So I3 would be minus 6. You see, it must be flowing outwards, and therefore will have a negative sign. So you'd say 4 plus 2 minus 6. Or putting it the first way I showed you, you could say 6 equals 4 plus 2. It's the same thing, just shown in a different way. The idea is we have a point, and the currents flowing into that point equal the current leaving that point. That is the essence of Kirchoff's first law. The second law applies to a circuit like this one. It says that the voltage applied to the circuit is equal to the voltage that are dropped across each component as we go around the circuit. So you see this one plus this one plus this one, all added together equal the 16 volts. And this applies to any loop in a circuit. Even if you have other connections that come off here, it's still true that the voltage around the loop is equal to 0. So I could say, in this case, we're going to say the voltage around that loop equals 0. Now we could actually work out what the voltages across the two resistances are, because we have the 16 volts here, which is pushing in a clockwise direction, and we've got the 12 volts here, which is pushing in an anti-clockwise direction. So the total voltage applied to the circuit is 16 minus 12. Minus because one's pushing clockwise, one's pushing anti-clockwise. And so we could say that is the voltage around this applied to the circuit. Now the current in the circuit is 16 minus 12. We say here I is 16 minus 12 divided by the total resistance, which is 8. So that's going to give us half an amp. Now we can work out these two, because a half times 4 equals 2. You see, I'm saying that the 2 volts is equal to I times R equals 2. There's another 2 here. So we got 16 minus 2 equals 12. Or the other way around, we can say 12 plus 2 equals 16. And that's called the Kirchoff's second law. It is when we have the voltages around the loop and we say they must add up to 0. So if we start at this point and gain 12, gain 2, gain 2, and then lose 16, we're back where we begin. So we can say 0 equals 16 minus 2 minus 2 minus 12. Alright, so that's how this Kirchoff's law applies. But now let's look at Kirchoff's law where the circuit gets a bit more complicated, and we can use Kirchoff's laws to solve the circuit to find our unknown currents. And what we're going to do to achieve that is we're going to change the circuit. Let's get rid of all this. And now I'm going to add an extra component. That's still 12 volts there, say. And we're going to add something just in here. Now in doing that, I'm making the circuit more complicated because I've got an extra component in there. And the current just here, we'll call it I1, is not going to be the same in general as the current here, which we can call I2. Now to work out I1 and I2, we can use the Kirchoff's laws. We can draw up an equation for each of the two loops. One loop here, loop number 1, one loop here, loop number 2. And we can say 16 for loop 1 is equal to I1 times 4 plus the voltage across here. So 16 equals that one plus that one. Now the current going down to the central resistance is going to be I1 plus I2. So the voltage across here will be 2, well, I haven't given it a number yet, have we? So let's call it 2 ohms. Let's say 2 ohms times I1 plus I2. And that's our first equation, loop number 1. Now loop number 2 is going to be 12 equals 4I2 plus, so that's that voltage there, plus the voltage across here, which again is the same as it was before. It's going to be this value again, which is 2 times I1 plus I2. And that's equation number 2. Now in solving those two equations, we can find out the values of I1 and I2. And in this way, we've used Kirchoff's laws to analyze a circuit. So the first thing you should do to do that is you make gather together all of the I1 parts. So that's got 4 plus 2 is 6 I1 and 2 I2. That's still equation 1, we just made it a bit simpler. And then we've got 12 equals 2 I1 plus 6 I2. So there we have equation 2. Now we can solve those two equations for I1 and I2. You can just use substitution, or any method will do. You can say, for example, that I1 equals 16 minus 2I2 all over 6. And then if you know that from 1, you can sub it into 2. And you can say 12 equals 2 I1, which is 16 minus 2 I2 over 6 plus 6 I2. Okay, so you see now this equation's only got one unknown in it. And so you can solve it through to find I1 and I2. So that's a basic introduction then to the way in which Kirchoff's law works to help us solve a circuit.